Modeling and solving problems with quadratic functions. We're going to start off with like a basic word problem where they give you the equation, they give you everything you know right in the question. It gets progressively harder to the point where you're not going to have equations, you're going to be building equations and stuff. And that's how it like really gets tough. So, to start us off, it says some engineering students constructed a potato cannon on the roof of a building. The height above the ground, h meters of a potato, t seconds after it's shot from the cannon is modeled by this equation. What do you know from the equation? From the graph, what is the maximum height of the potato and how long was it in the air? So, read the question once, got an understanding for what's going on. Someone's got a potato gun and they shoot it. Sounds kind of cool. I actually do that a lot of the time. We can. But if you go to university and become an engineer, you probably do it as a fun project. Now, we're going to read it and try to draw info from it. If you read it again, it says some engineering students constructed a cannon on the roof of a building. The height above the ground is h meters. So h equals height. Of a potato, t seconds after it's shot from the cannon. T equals time after shot. And it's modeled by this equation. So they gave you the equation. That's nice. In this question, they've even graphed it for you and shown you a picture. When you graph this function, it would only make sense to look at the positive part of the graph. Right? Your time, you don't care about anything less than 0. Because that's negative time, it's not actually a part of this question. You don't care about anything below 0 for the y's, because that's negative height, and that's not going to matter for this question really either. So you only did the positive part, the positive y's and the positive x's. When you graph it and you get that quadratic, or that little line there that they have in red, this is the potato. Right? Anything that you graph should be representing something. In this case, that's the pathway of the potato. So you can picture it. When you shot it, it started right here on the roof of the building at 0 seconds. 1 second later, it's traveled all the way up to here. In 2 seconds, it's traveled all the way up to here. 3 seconds, it's traveled to here. Right? This is the path of the potato. And any question like this, whether it's a football or a potato or a golf ball or a soccer ball, or if it's someone throwing a hat or jumping off of a cliff, like your quadratic is representing something. It's usually representing the pathway of something. That sometimes helps people when they don't understand that their quadratic actually does mean something. Once you realize that, it sometimes makes the question a little bit easier. The first question says, what do you know from this equation? What are some things that we know? Okay, what does that mean about this question? The building is 10 meters tall. The y-intercept, that's you standing on top of a building. So it's a 10-meter building. That's something you know. You're right. Looking at that graph, I know that. What's something else I know about this potato after I shoot it? You know your vertex. It's at 2,30. And Jenica's right. That means something. That's telling you the maximum height is 30. So the potato reaches a height of 30. And that's something you know just by looking at this graph. You have a maximum height of 30. Yeah, it will be, yeah. What else do we know just looking at a graph like this? You know how long it was in the air for, when it lands. Right? This is the potato. It eventually hits the ground right there. So if I said, how long is the potato in the ground, you would know it's 4.5 seconds. Like, those are all things you know when you look at a graph. You know what its maximum height was. You know the most amount of time it spent in the air. You know the height you shot it from. You also know how long it took you to get to your maximum height. So if I said, how long did it take to get to your maximum height, you would say 2 seconds. It's like you know a lot from these graphs. And that's why we analyze them. So the question at the bottom in Ewan's rate, it says, from the graph, what is the maximum height of the potato? The maximum height was 30. And how long was it in the air? It was in the air for 4.5 seconds, because it started at 0 seconds, and it eventually landed at 4.5 seconds to hit the ground. People don't realize there's a lot to a graph when you look at it. Any questions about those things? Analyzing a basic graph. Alright. Design questions. This one's a very basic design question. And understand that if you can solve this design question in your head, that's fantastic. Okay? But you're going to have to know how to do these types of questions. Just a little more complex, right? There's lots in your practice booklet. There's a couple in your assignment. We do a basic one as an example so that it's easy to understand and there's not too much confusion with it. So this question says, a person has 100 meters of fencing to enclose a rectangular garden. What are the dimensions of the largest possible garden? I read it once, then I'm going to try to draw some info out of it. A person has 100 meters of fencing to enclose a rectangular garden. They have a garden, it's rectangular. They have 100 meters of fencing. That's telling you something. I'm not sure why. Think, without thinking about actual like math, like y's and x's. If I told you you have 100 meters to build a fence, that means your perimeter equals 100. I think that's the area around the outside. That's how much material you have. What are the dimensions? Dimensions means length and width. What is the length and width of the largest possible garden? That means largest area. That's what I'm looking for. What length and width give me the largest area? To do a question like this, you have to figure what you're trying to maximize. Right? I'm trying to maximize my area. What's area equal? Area equals length times width. That's what I'm trying to maximize. I can't maximize something with two unknowns. I always need just one unknown, right? This 100 perimeter is important. They had to tell you how much fencing you have. What's your formula for perimeter? Oh, you're thinking harder. That's like a circle. Perimeter is 2 lengths plus 2 widths is equal. Okay, perimeter is the area around the outside. If I went length plus width, it would equal 100 meters. You have to somehow take the info they gave you, the lower perimeter, and link it to this thing up here. We did a little bit of this a couple days ago, I think on Thursday. This is a system of equations, essentially. So if you want to somehow link this into your area formula, you need to get length or width by itself. So if I rearrange this, I can rearrange it so that 2 lengths equals 100 minus 2w. Maybe if I move my 2w's over. And then if I get length by itself, I divide by 2, and means length equals 50 minus w. My length will be equal to 50 meters minus however much I've used for my width already. We can substitute that into our area formula. So now we have area equals your length 50 minus W times the width. Now I have my area, but with only one variable. Whenever you have an area formula, you're trying to solve something in it or maximize something in it, you can't have length and width. You somehow have to get rid of one of them and turn it into the other one. That's what we were doing. We were creating an area formula that's just widths. You could have also done it as just lengths. That would have been fine. Now, looking at that thing, the question is, maximize this. How do you find maximums in this class? When have we ever used the term maximum before? Like largest means to maximize. So when have we ever maximized something? We've used the word maximum a whole bunch of times. Where do you see it?
Your calculator.
You see it.
Graph goes.
You see it in your calculator. So if you see largest possible, or if you see maximum value, that's them saying find your vertex. So find your vertex of this equation, where area equals y and width equals x. And find your maximum. That'll tell you your maximum area and what width gives you that maximum. If you put this in your calculator, you should get a little quadratic. Quadratic looks like this. Remember, you're only going to look at the positive end of things. The smallest width or length that you could possibly have is 0. The biggest possible length or width that you could have would be 50. And 50 doesn't really make sense if I used it, but that's the maximum amount you could have, because if I had 50 on my length, 50 on my other length, that would be all 100 of my material. That would be just a straight line of fence. So that's how that works. So this would be 50 over. My area, the smallest amount of area I could have is 0. The most amount of area I could have, I would just guess it to be about 150 for a window. Something nearly. I'm going to guess like 70. See if that works. I might have to change that, right? So when I'm setting my window, I might have to make my Y maximum bigger than 750 if I can't see my whole graph. I might have to make it smaller than 750 if I can see too much of my graph, right? But I adjust off of this estimation. This is just me thinking about it first, like just logical reasoning when I set my window. My X value is my length. The least amount of length I could have is 0. My Y value is my area. The least amount of area I could have is 0. The most amount of area I could have, I really don't know. That's what I'm trying to find. But if I were to guess, like, I'm going to guess it's going to be around 750. I might even have to go up from there. It's just a guess, like a good estimation. Can you graph it? Is 750 enough to see the top of your quadratic? 1,000? And you can see the top of your quadratic?
Yeah.
Awesome. So as long as you can see the top of your quadratic in your graph, you're good. Is anyone having a hard time graphing it? Yeah? You put it in? Just gonna take a peek and see what's going on. That's a great question. So anytime you read a question that says the words largest, if you're trying to solve for a largest, that's them saying that you need to maximize something. And that's the key word that says I need to graph. Because the only way we've ever found maximums is graphing. If it said minimum, if it said let's do the smallest possible garden, then I'd be looking for a minimum. But that's the key, knowing you have to do this. You will get a question like this. Just a little more jacked up and difficult. And there's a bunch of them in your practice booklet and assignment. You'll see them. That'll be on your calculator part. Yeah, exactly. We'll talk a little bit more about that at the end. Just remind me this. Okay, so your window setting. You're shooting on X minimum of 0, X maximum of 50. Your area setting, Y minimum 0, Y maximum 750. If you don't remember to find your window setting, it's the little skinny buttons across the top. One of them should say window. That's where you get to set those things up. When you find your maximum, what point is this right here? Anyone found it?
25
and what? So that maximum, that vertex is telling you something. It's saying when X is 25, Y is 625. In context of this question, that means when width is 25, your area is at its absolute maximum of 625. If I made my width a little bit smaller, my area would go down. If I made my width a little bit bigger, my area would go down from that point. So when it says what dimensions would create the largest possible area, my width would have to be 25. And I would have to then put that into my other formula over here to figure out that my length would also be 25, which is a square. Squares are rectangles. Squares are special rectangles where the length and the width are the same thing. But a square fits the definition of a rectangle. So you would take this 25, you would set it into this formula to figure out length also equals 25. 25 by 25 would be the dimensions. And a square is a rectangle. That's why some people can solve this thing kind of in their head. They just know that area is always, if you can get the sides closest as possible, that always makes the biggest area. The way a question like this gets harder is if they do some sort of shape. Like maybe you have a square or a rectangle like this, but you want to build a fence down the middle. Then your perimeter wouldn't equal 2 lengths plus 2 widths. Your perimeter would be 2 lengths, 1, 2, and then 3 widths, because you had to do an extra fence down the middle. Yeah, that's how they make the questions harder. They change the perimeter formula. They don't let the perimeter formula be this basic one. They add an extra side somewhere. They say, okay, you want this as your garden. There'd be 1 big length all the way across, and then 1 big length all the way across. If you did it as 4, it would work too, as long as you kept that formula the same. But that would be a weird way to do it. Down here? This is width 1 plus width 2. And plus width, the length 1 plus length 2. That's why it's 2 and 2. There's questions like that in your practice. I highly suggest you try them. Yeah.
So the one on top would be like
That'd be 2L plus 3W. Yeah. The old I wouldn't do 4L just because. Again, that's kind of what you were thinking too, right? Like, I want to maximize this whole area, so this is a big length all the way across. If I'm thinking of these little lengths, I'm going to end up maximizing just a bit, and that's going to screw it. You will have to do questions like that. This is your warning. Okay. Another one. So this one is one you're going to have to build. It says find 2 integers with a sum of 24 and the greatest possible product. Greatest possible product. Greatest means the same as largest. We just learned that largest means to find the maximum. So somehow we are going to have a graph and we have to find the maximum. Reading the question again. It says find 2 integers with a sum of 24 and the greatest possible product. The first sentence creates the equation for you. 2 integers, I should use blue. 2 integers. What are those integers? X x and y. We don't know what they are, right? There's two integers. You have x and you have y. With a sum, what is sum? Sum means addition. So, two integers with an addition, x plus y, of 24 equals 24. There's two integers with a sum of 24. And find the greatest possible product. What's the product? What does product mean? Not add, multiply. They want you to maximize this. Find the greatest possible product. Maximize the product. The product is x times y. You can't graph when there's two different variables. So you have to somehow turn one of these so that it's into the other one. How can I change one of these x's and y's so that it becomes an x or a y? Solve the one on top. If you could rewrite this so that it's x equals 24 minus y, then you could change this x to be this thing right here. Then you have y's, right? You would only have y's in your equation. My new equation would be product equals 24 minus y times y. They gave you two equations. You had to build both of them. They wanted you to maximize one of them. You use the other one to make the other one so it's actually graphable. In this case, if you were to graph it, your product is your y equals, and your y values in this case are actually your x's in your calculator. It just represents a number, right? If you graph it, you're looking for the highest point, the maximum on the graph. You're going to end up figuring out that x equals 12 in your graph. So if you had an x value of 12, it would give you a product of 144. Is that the maximum of your graph, those of you who are graphing it? Yeah? So if your x value is 12, what should your other number be? That's the product was 144. What is the other number having to be? It would also be 12, right? Because a number plus a number equal 24. If one of the numbers is 12, the other number has to be 12 as well. We went down one kind of fast. I just don't like that question. There's a couple better examples in your practice booklets, but at the end of the day, you create an equation, and then you figure out what you're trying to maximize. In this case, we want to maximize a product. Yeah. Yeah, so if it was a written response question, you got to show some work. If it's a numeric response or multiple choice, you just get it. Yeah, you'd get the mark. These ones are easy to solve in your head if you have a good understanding of how to maximize multiplication. Like that square with the rectangular garden one. Anyone who's like remembered that little trick that like a square always has more area than a rectangle, like you could solve it really fast. Right? But it's the process that's more important. Yeah. Yeah. The other thing is, I know that the questions are going to be more challenging. Like with that garden one, you're not going to get a square garden as your answer. Maybe on a quiz or something, but probably not on the test. Excellent. Two numbers have a sum of 20. Does the sum of their squares have a maximum or minimum value? Determine this value and the two numbers. Look at the words. maximum or minimum. You're going to be looking for a vertex. You're going to be graphing. We're going to build an equation that fits this. So it says two numbers. What are those numbers? Do you know what they are? They're x and y. Have a sum of 20. X plus y equals. That's the first equation that you're given. Does the sum of their squares have a maximum or minimum value? What would the sum of their squares look like? So sum of squares. Sum means to do what? Add. Let's mean when you do squares. It means you actually square. If it's in the root of them, that's how you do square. That's the sum of their squares. X squared plus y squared. The question says, does the sum of their squares, does this, is it a max or a min? And then what is the maximum or minimum? Knowing what the question's asking is like half the battle, and setting it up is the other half. You guys get pretty good at the calculator stuff. How do I find maximums or minimums? I graph them. I can't graph something unless I get rid of one of these to become the other one. How could I change it so that I only have one variable instead of two variables? You have to isolate using this one. So for instance, I could change that to y equals 20 minus x. That means I can use that y value and substitute it into the other one. So now I have this. Right? I substitute that y out to be 20 minus x. I use the other equation to get rid of one of my variables in the other one. Now you need to graph this and find the max or min. Find out if it is a max or a min. So, yeah, you can. If you graph this thing, the window's going to be hard on this one. Okay, so if you just use a standard window, that might help. If you want to try to use some inklings of x and y, that works. You could be like, well, x could be 10, y could be 10, and try to create something off of that. That's fine too. On a question like this, I'd probably just start with my standard window and then grow from there. They should be pretty simple. If you're not sure, look at what you're graphing. And that should give you some sort of clues about your window. Like this thing, if you create a quadratic, you could always change it into a different form so that you have some sort of idea what it looks like. And that might help you as well. When you graph it, you're going to end up getting a quadratic that is facing upwards, like this. Any quadratic that faces upwards has a maximum or a minimum. Minimum. So the answer to the first question is it has a minimum because it's opening upwards. What is the minimum? What is that point when you find it? Can we find it? 10,200. 200? So when you graph it, that's the value you find, 10,200. That means that 200 is the minimum value for the sum of their squares. And x equaling 10 is what creates that minimum sum of squares. If 10 is the sum of squares, or the number that creates that minimum sum of squares, the other number be. this number was 10, the other number would have had to be also 10. If this number is 10, go to that formula. 10 minus 10 would be, or 20 minus 10 would be 10. These questions are kind of tricky. You're always going to have two equations. One of them is going to be a max or a min. The other one's used to turn the other one into one variable only. There is practice in your practice booklet, so good try. Yeah. Yeah, so if you actually tried it and you knew you had 10 and 10, you could put both of these back in your question. 10 squared plus 10 squared would be 200. Yeah. You could actually verify to see if it works. Yeah. And it worked, right? Yeah, that's good usually. There's one more, like this. We're going to skip it for now. We'll come back and you can practice it on your own. It's a practice problem for you anyway. But we need to try to get through these next two. We have two more. There's guaranteed you're going to get one like this. And they're hard. That's how we're going to do it. I like these questions the most of most of the things we do in this unit because it's the most realistic and it's something that people actually use in the real world. So the question says, student parking passes cost $20. At this price, 150 students will purchase passes. So that means if I set the cost for parking pass at $20, 150 of you will buy them. For every $5 increase in price, 20 fewer students will purchase the passes. So if I take my price and I say instead of $20, now it's $25, that means 20 less people will buy them. What is the price of a parking pass that will maximize the revenue? That's a tricky question. Okay? And it's a realistic thing, and this is actually how people would solve it. They just do it on way bigger schemes in the real world. So anyone running a business wants to maximize their revenue, right? What is revenue? Revenue is how much money you actually generate. So, how do you figure out how much money you've generated?
Number of sales.
You go number of sales times your price. Revenue is not your profit. It's how much money you got. How much you gained. So for instance, if I have cans of pop, I'm selling them for $1 each and I sell 5 of them. How much revenue did I make? I made $5, right? Now maybe those pop cost me $20, so I actually ended up losing money. But the revenue was $5. It's my sales times my price. You will not be given that. You just need to know that revenue is sales times price.
Do we have the ones in here where we have to do actually calculate profit and revenue and then take it away from each other?
Yeah, these questions are kind of, then it gets a little harder than this too. Okay, we want to maximize our revenue, right? That's what the question said. Maximize revenue. Right now, I can't graph sales and price. I can't type in my calculator sales and price. Instead, I have to have two formulas for sales and price. Let's start with price, because that's usually easier. What's my price of a parking pass? My price is $20, right? It said it right here. Parking pass costs $20. That's what it used to cost. What am I going to do to that price? I'm going to increase it by $5. It says for every $5 increase. Did it say how many times I increased it by 5? No. So I'm going to say $20 is my price plus $5, and I don't know how many times I'm going to do it. So I'm going to say it's 20 plus 5x. X is the number of times I'm going to increase my price. I'm going to also write that down. X is the number of increases. My sales. You're too far ahead of us. Hey, what? Okay, and I'm telling you that these questions you won't be able to do that on. Like, it's the thing. You get so caught up in wanting an answer, right? It's the process that's going to get you there. And I've already warned you that these questions get harder than being able to guess and check. The sales. How do you calculate sales in this question? I have 150 sales, right? 150 students will purchase the passes. But that's at the old price of $20. So I have 150 people, but every time I increase the price, what happens to the sales? 20 fewer students will purchase them, so minus 20 X times. I don't know how many times that's going to happen. It could be one time if I do one price increase. It could be 10 times if I do 10 price increases. So those are your sales and your price formulas. You need to substitute those back into your revenue formula. So my revenue formula now is 150 minus 20x, and then 220 plus 5. You can graph it just like that. So you don't need to expand it. That's just factor form of a quadratic. Before you graph it, so let's not get too crazy yet, I want you to go to your window settings. We're all going to do this together. Because setting the window for a question like this is hard. So we're going to set our window together. Alright. We're going to start off with our X minimum on our window. What is X in our question? X is the number of increases, exactly. How many times I raise the price. What's the least number of times I can raise the price? Even less than 1. I could just leave the price at $0 or at $20 and increase it 0 times. What's the most number of times I could increase the price? Infinity, technically, how many could I logically do it?
Until you run out of people to buy it.
Until you run out of people to buy it. So if I started with 150 sales and I'm losing 20 sales every time I increase the price, then I could really only increase it 7 times. On the 6th price increase, or on the 7th price increase, I've lost 140 people. On the 8th price increase, I'm now at negative people. Because now I'm at negative 10 sales, and that wouldn't make sense. But I'm giving away 10 passes. So I would actually, probably, just so I can see my x-intercept, I would go 1 pass. I do it. So then I can actually see that x-intercept. It probably helps the graph. Y minimum. What is y in this graph I'm going to graph? My revenue. What's the least amount of revenue? What's the least amount of money you can make? You can make $0. Here's the hard one. Y maximum. You're not going to know a good number to put in for Y max. That's what you're trying to find. It's the maximum revenue. But what I do know is what my old revenue was if I never changed anything. If I had never changed the price, what was my old price? $20. And how many would have I sold? 150. So my old revenue would have been $3,000 if I multiplied those two things together. Ideally, what do I want to do to that revenue? I want to increase it, right? Ideally. So if I could take a $3,000 revenue and I could increase it to like $6,000, I would be really happy. So I put 6,000 as my Y maximum, and it's just a flat-out guess. It might not be high enough. It might be way too high, but at least I'll be able to see my graph because it makes sense. It's a logical guess at a revenue. There's something wrong with the graph. Yeah, I'll help you out. Your X and Y scales should both be 1 and 1. I want you to try to graph that thing and find the maximum point of that graph. If you're having trouble with the graph, let me know and I'll help you. Okay. When you graph this thing, you should have got a graph like I put on the whiteboard over there. It's just a little quadratic that kind of looks like this. So people watching it right. When you went second trace maximum, you should have found this point right here. What was this point?
1.7, 3,036.
You got 4.7?
1.7. Is it 4?
No, I didn't hear.
1.74. 1.74.
7, whatever, and then
1.75, and then.
And what's the next one?
3,306.2 or 0.3.
Hour. So when you found that point, you should go 1.75 price increases. Would give you a revenue of 3,306. Point whatever. That's what that point means. 1.75 price increases gives you a revenue of 3,306, and that's the most revenue you could make. Now, a question like this does not have partial revenue or partial price increases. So you are not going to do 1.75 price increases. You're going to do one price increase or two price increases. And you're just going to round logically with a question like this. So my next closest point would be 2. I know it's not my exact maximum, but it's closer than if I did 1. That means x equals 2.
Lots of questions where it's like you have to think like you wouldn't have like a half book pricing.
Yeah, there's a lot, a decent amount. It's just always around it. And if you think about it logically, you should be set. Yeah.
I wouldn't have thought about it until you said it.
And a question like this, I get 1.75 as an answer a lot. I also get 2 as an answer a lot. And neither one of them are right. Well, what's the question asking? What is the price of a parking pass that will maximize the revenue? The question was, what is the price? Price was 20 plus 5 times however many increases you did. X was the number of increases you needed to maximize your revenue. But it wasn't the price that maximized your revenue. The price that maximized your revenue was 2 price increases, so it was $30. Because I started at $20, I increased it once by $5, increased it again by another $5. 30. You can use your price formula you created.
Oh, I didn't put on this too.
Oh, you did 1.75. Yeah. Make sure you have to round to 2. Yes. Because you can't do a partial price increase. You're doing a full increase or not. Make sure you're answering the question. The answer to A is $30. It's not 2. 2 is the number of increases you did to the price. Yeah.
When you round at the very end, like you'd add the 1.75 and then you round up like some number around 30.
If you do 1.75, that means you did one increase of $5 and another increase of 0.75 of $5. You won't do partial increases. You either go all the way up and do a $5 increase, or you don't do the increase at all. So you have to round first. Question 2, what is the maximum revenue? The maximum revenue is not $3,306. You need to take your value of x equals 2, and you need to actually substitute it in here and calculate what you get. So you're going to have a price of $30. You end up having a sales of 110 people. So you end up with 30 times 110. And that tells you what your maximum revenue actually is, which is $3,300. But you use the value of x to answer those 2 questions. Y is your revenue.
Like in our math.
Or revenue. Your slides. You're guaranteed going to get a question like that. First time you see it's kind of hard. That's why we have a second one on the next page.
So would you have to fill it in, or could you just use your Y?
Your Y value wasn't rounded. Right? Your Y value was 3,306 because it was using 1.75. So you have to round the 1.75 up, and then you have to round the revenue.
Three more?
Okay. Yeah.
We can just do it by taking the 40 people off and then increasing it to 30 until you get the answer. I did that at the very start and I got access to it.
For sure. Use that method on test. Like, feel free. You only have an hour and a half for your test. And when the revenue is like $1.5 million and they want to know how many price increases to do, see how it goes for you. Like, these are basics so that you can try to understand the word, and the numbers are going to grow, right? And the problem's going to get a little more challenging. Like, yeah, you got to trust me when I'm telling you, like, learn the process. Because eventually it's going to get to a point where you can't guess and check. Or you can guess and check, but it's going to take you a solid half hour. And you only have an hour and a half to write the whole test. Like on a unit test, you only have an hour and a half, right? Okay, there's another one here. I'm going to give you 3 minutes, not 2 minutes, to see if you can set it up. Okay, that's all you have to do. You're trying to set up an equation, not answer it or anything like that, but set up the equation you actually want to maximize. In this case, you're maximizing your revenue again. So to maximize your revenue means you need to have revenue equals something to actually graph. Building this together. It says every week a takeout restaurant sells approximately 2,000 chicken wraps for $1.50 each. Your market research, the manager determines that for every 5-cent increase in price, she'll sell 50 fewer wraps. I started with 2,000, I'm going to sell 50 fewer. I started at $1.50, I'm going to increase by 5 cents. They even put the decimals in to make it nice and easy. What is the price of the wrap that will maximize the revenue? So I want to maximize my revenue. Revenue is equal to however many sales you have times whatever your price is. I don't know what my sales or my price are because it's dependent on how many increases I do. It's dependent on X equaling the number of increases. X will always equal the number of increases in these questions. Sometimes it's a price decrease. That's possible. But you should understand X is always the number of increases or decreases you're doing. It's a given. So if you always want to write that down, it might help you remember that that's not actually your answer to things. It's helping you answer your question. To be able to do revenue equals sales times price, I got to figure out what my sales and my price are. My sales was $2,000. And I'm hoping to change it. I'm going to actually lose 50 sales by every change I make. So minus 50x. I'm going to take my old price of $1.50 and I'm going to increase that price by 5 cents. X number of times. I don't know how many times I do that. I'm shocked that no one asked the question like, how do you make more money if you have less sales? That's always a question that comes up. You're like, you're losing sales, but you're making more money? It's because the amount of extra money you get from the increased price makes up for the money you lost from these additional sales. So nobody asks that. Usually that's a question. These are your formulas that you put into your revenue formula. So the thing you actually try to graph, the thing you actually try to maximize is this formula right here. That's what I want to try to maximize. Revenue is my Y, X is my number of increases. Before you graph it, I want you to try to set a window for it. Okay, so I'm going to give you 30 seconds to a minute to set your window, and then I'm going to talk you through how I would set my window and see how close you are and see if it works. Right? But try to pick a window setting just for yourself. My X minimum. In this question, what is X? What does X represent in the questions? The 0 is a great answer for X minimum, but what does X represent? X is the number of increases. The least amount of increases I can do, the minimum amount, is 0. It's the minimum amount of increases I can do. What's the most number of increases I would do to this thing? Why 40? It's a great answer. Yeah, that's actually perfect. But I don't think people would follow you. I'd follow you. That makes complete sense. The way I knew 40 would be my maximum number of increases is I'm losing 50 sales every time I do an increase. So once I got to 2,000 sales lost, I would be done selling things at all. And to figure that out number, you can just guess and check a little bit and see what number would make that happen. Eventually, you should land on 40. 40 times 50 is 2,000. 2,000 my sales would be 0 sales. Yeah, you could just solve that thing if you wanted. Yeah, like a 0 product property, essentially. All right, Y minimum, Y maximum. What does Y represent in this question? Y is my revenue, right? When I graph this thing, I'm graphing my revenue. What's the least amount of money I can make? $0. It's crappy revenue, but it's still revenue. Anything less than that's unrealistic. My Y maximum, my revenue maximum, that's the hardest one to do. I base it off of what my old revenue was. So if I made no changes to this, no changes means I had 2,000 chicken wraps. I sold them for $1.50 each. That's $3,000 in revenue. That's my old revenue. If I could take 3,000 revenue, change it into 5,000 revenue, I would be a very happy person. Now that's probably too lofty of a goal. If it is, then I adjust my Y maximum after I graph it. If it's not lofty of enough of a goal, then I'll notice that I can't see the top of my graph, and then I'll adjust my Y max to be bigger. But I can always adjust based off of this. This will always show me the meat of my quadratic. When you graph it, can you see the top? Is 5,000 a big enough max? Yeah? So you can see the maximum of the vertex? Oh, sorry, of the quadratic? That's good. Yeah. It will not. You will not be asked for window settings. On your unit assignment, I believe there's a question that says window settings on it. You do not have to do the window settings part. I think I deleted it out.
Okay, I still don't want to grade 10.
In grade 10, they made you do it a few times? Yeah. I think there's one in grade 11, but I think I took it off. Yeah.
It's supposed to be a maximum.
And you're looking for a maximum. If you're not getting a maximum, you probably have a minus or a plus here that's wrong. So check what you graphed. Your formula is probably off. You probably have a negative or a positive there where you meant to have something else. But you definitely should have a graph going downwards. One should be positive, one should be negative. Because I was adding 5 cents to my price. Okay, when you graph that, you get a quadratic that looks somewhat like this. The maximum is right here. What point is it? Somebody find it yet? Oh, 1.7? 5.7?
I just don't saw that.
Yeah, 5.
3,062. 5? Okay. Did anybody else get that? We got better check. It's probably just a decimal thing. If not, I'll come look. See if you can regraph it. You might have clicked an arrow over right after you graphed it. It might have pushed it one to the left or right. That happens. Try to do it again if you can, but I'll fix it. Okay. Neither one of those are the answer. This point, 5 is the number of increases, so it'll give you a maximum revenue of $3,062.50. The question was, what is the price? The price is $1.50 plus 5-cent increase 5 times. So the price is $1.75. Make sure you're answering the question when you do these types of questions. X equals 5. That's the number of increases. What would my sales be that would give me a maximum revenue? That would be my revenue. Sales would be 2,000 minus 50 times 5. So it would be 2,000 minus 250. So it would be 1,750. But right, you could ask so many questions on this. You have to be able to answer the question based off of this math. All right, enjoy the rest of your day.